Hello everyone, so today in this video we are going to solve a question of LeetCode, that is max area of island. This is 695th question on LeetCode and this comes under medium category. Alright, so let's start with the problem statement. You are given an m into n binary matrix grid. Right, this is binary matrix, so it must be containing 0 and 1. An island is a group of ones connected four directionally. Right, we need to find out the island which is connected four dimensionally. Four dimensionally means upward, downward, left and right. This is the four direction. You may assume four edges of the grid are surrounded by water, and the area of island is the number of cells with the value of 1 in the island, right? So we need to return the maximum area of island in the grid. If there are no island, return 0, right? So what we need to do is we need to find out the maximum area, right? There are multiple islands, right? There may be multiple islands in this grid, so we need to find out the maximum area of that island, right? So let's quickly understand with this example. Let me just copy it from here. Alright, so this is the first example. In this first example we have multiple islands, right? So let's say we have an island of 1. This is the first island, right? So for this first island we will get area equal to 1 because there is only one element, right? For this we have 4 elements, so the area of island is equal to 4. We are considering area as a number of count of this ones, right? So we have a possible answer 1, then we have 4, this is 4, right? Then for this is one island, so for this the area is equal to 5, right? For this upper one the area is equal to 4, right? For this the area is equal to 5, and for this the area is equal to 6, right? So we have total 6 islands, right? 6 possible islands. So in this 6 islands the maximum one is equal to 6, so we will be returning 6 in this case, right? We will be returning 6 in this case. Now let's understand how can we approach this question. So to approach this question, what we can do is we can use two types of method. First is a DFS and the second is a BFS approach, but in this video we will be discussing only the DFS approach because it is more easy to understand and it's quite intuitive. So let's quickly see how can we do it through a DFS approach. So in the DFS approach, what we will do, we will first check for each element, right? So we will start from here. Let's say we will start from here. If this element is equal to 1, right? If this element is equal to 1, then what we will do, we will call a DFS function for this, right? We will call a DFS function of this. Since this is not 1, so we won't be calling a DFS function for this. But let's say if we come to here, right, in after some iteration we come to this point and this is 1, so what we will do, we will call a DFS function for this, right? We will call a DFS function for this, and in that DFS function what we can do is we can find out all its neighboring element, right? All its neighboring element. Now what are those neighboring elements? Let's see. So the neighboring elements would be, let me just write it here. Let's say this is a element, right? This is a cell, and what are the neighboring ones? So let's say this is the neighboring one, this is the first one, this is the second one, this is the fourth one, this is the third one, this is the fourth one. So let's say there are 4 neighbors of this, right? So what are these 4 neighbors? Let's say this element is I comma j, right? This is the I comma j. So the neighbors would be, right, the neighbors would be, this should be I, right? The row will be same and j will be -1, right? So this is one neighbor, and the second neighbor would be I will be same, right? This is the same row, and j will be incremented in this, so j plus 1, right? Now the neighbor, the upper one is equal to this I will be decremented, right? I -1, and j will be same because this is the same column, and for this down one the I will be incremented, I plus 1, and j will be same, right? So these are the 4 neighbors, right? These are the 4 neighbors of a single element or the single cell. So what we will do, we will just call a recursive function for this, and for each value, right, for each one in the cell, we will just increment the answer, right? We will just increment the answer in the recursive call. And at the end, what we will do, when we call a recursive function for each of the element, let's say we call for this, so in the recursive function we might go to other elements, right? So whenever we are calling for one, so after calling for one, we definitely be going to all the ones, all the neighboring ones. So what we will do, when we will visit these elements, we will just mark it as visited. So to mark it as visited, we can mark it with some other value, right? So let's say we mark these elements at 2, right? So whenever we will visit an element, we will mark it as 2, right? We will mark it as 2, so we don't need to waste our iterations again and again, right? So this is the first thing, that we need to check the conditions of neighboring one. Then the second thing is we need to mark it as 2, right? So these are the two conditions we need to keep in mind. And yeah, let's quickly code it up. I hope the approach is clear to you. This is pretty easy approach, and we are just calling the DFS functions here. And let's quickly code it up and you will understand it better in the coding part. So yeah, let's quickly move to the coding part. So in the coding part, let's start the, let's first take int m. Will be storing the size of the rows, right? So m is equal to grid dot size, this is equal to the number of rows. And let's take another integer, int n is equal to grid 0 dot size, this will be storing the number of columns, right? Now let's run the for loop to visit each columns, right, for to each cell, right? So call a let's run a for loop. Int I is equal to 0, I should be less than m, and I plus plus. And let's run a nested for loop for the columns. So int j is equal to 0, j should be less than m, n, and j plus plus, right? So in this for loops, right, in this for loops, we will be visiting each elements, right? We will be visiting each element, and we only need to consider those elements which are one, right? Because we are only considering the one elements because they are considered as island, right? So let's see, let's write if grid I and j is equal to 1, right? If it is equal to 1, then we will be updating the answer, right? So let's first declare our answer variable here. So let's take int answer is equal to 0. Initially it is 0, right? Because it is given. Return the maximum answer, and if there are no islands, then we are returning 0, right? If there is no island, we are returning 0. So why not to initialize it with 0, right? So we are just initializing it with 0 because we are considering that initially there are no island, right? So whenever we will get an island, so we will just update with the maximum value of island, right? So maximum of answer, and let's call DFS for this. So DFS grid, let's pass grid from here and pass the indexes of the current cell, so I and j, right? So this is a DFS function we will be declaring very soon in this video, and let's return answer from here. Now let's declare this DFS function. So this DFS function will be returning int, and let's write DFS, and it will be taking a vector of vector grid, right? This will be taking a grid, then two integers int I and int j, right? Now what are the boundary conditions for it? Let's see. The boundary or the edge conditions are when this I, right, when this I is going out of this 0, right? If this I is less than 0, right? If this I is less than 0, it means it is going out of this left side, then we don't have any element, right? So this is one edge case. Then the second edge case is if j is less than 0, right? If j is less than 0, then it is going beyond this upper side in the recursive solve. So this is the second boundary condition. Then the third boundary condition is if I is greater than equal to the size of or the number of rows, right? If it is greater than number of rows, then we will be returning 0 because we don't have any element here. And the fourth boundary condition is j is greater than equal to the number of columns, right? If it is greater than number of columns or equal to number of columns, then it might be going out of bound, right? It might be going out of bound, because if it is equal, right? If it is equal, since this is a zero indexed array, it is a zero indexed array, so we won't be considering the equal elements, right? We won't be considering when the value of this j is equal to this c, right? The size of c, because the number of elements, like the last index will always be equal to the size minus 1 in the zeroth index array, right? So we are just considering when j is greater than equal to c, then we will be returning 0, because we are going out of bound and we don't have any element here, right? And the last and the fifth condition is, so when the value of this cell is equal to 2 or 0, right? These are the two conditions. If it is equal to 2 or 0, then we need to stop this iteration, right? We need to stop this iteration. So we will keep the fifth condition is when we will get 0 or 2, or we can say when we will get the element which is not equal to 1, right? When this element is not equal to 1, then also we will be returning 0 from here, right? So these are the 5 conditions we need to keep in mind, and let's write these 5 conditions here. So let's write, if I is less than 0, right? This is the first condition. Then the second condition is when j is less than 0. Then the third condition is when I is greater than equal to grid dot size, right? And the fourth condition is if j is greater than equal to grid 0 dot size, this is the number of columns. And the fifth condition is if grid I and j does not equal to 1, right? If it is does not equal to 1, then we need to stop this iteration. So let's return 0 from here. So now let's update the element which we have already visited. So let's update grid I and j with 2. It means we have already visited this element. Now let's call the recursive call from here. So return 1 plus DFS. Let's write all the 4 conditions, four statements here, in which we will be calling all the neighboring elements. So DFS grid I and I plus 1 and j, right? In this we are calling the right element. Then DFS grid, this should be the bottom one, right? Like the next row, this is I plus 1. Now this is grid I minus 1. This is the upper one. This is the upper one, right? The upper one from the row. So this is the second, and the third one would be DFS grid I and j minus 1. This is the left element of the current cell. And the fourth one is DFS grid I and j plus 1. This is the right element. Alright. And we need to add this one. So let's add all the values. So these values will be added. And yeah, I hope this should work fine. Let's just run it. Yeah, it's working fine. So let's just submit this. Yeah, it's working fine. So let's calculate the time and space complexity of this solution. So the time complexity of this solution is big O of n into m, because we are traversing through all the cells of this given grid, right? We are just traversing through all the elements of this given grid, and we are just, right, we are just saving some iterations by adding this condition, right? We added this grid ij is equal to 2. It means we are not visiting that element again. That is why the time complexity is n into m, because we are visiting all the elements of the grid only once, right? And the space complexity is big O of n into m, because the recursive stack will take around n into m space, right? So that is it for this video. I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to the channel. I will see you in the next video.